Asha from Institute of Engineering and Technology from the Department of Electronics and Communication Engineering. Today I am going to explain you two topics about design of FR filters by windowing technique and the Gibbs window from the subject of digital signal processing. The first topic is advantages of FR filter. What are the advantages of FR filter comparing to the IR filter? So first of all, FIR filter means finite impulse response filter, right? So if we are taking the finite impulse response only, so it will give you the stable output. So always it will be stable. Now the next disadvantage is linear phase response. It will give you the linear phase response. So because of it, we can directly calculate the symmetricity or anti-symmetricity and will applying it for stable output. Now the third advantage is FR designing techniques can be easily optimized. The next advantage is recursive and non-recursive filters can be designed. Now what is the meaning of recursive? Recursive means with feedback if we apply the filter designing, then also we can design it, and without feedback also we can design the filters. The next advantage is minimum round of noise error. So when we are converting analog to digital form, so it will give you the rounding errors, right? So it will be minimum for this finite impulse response because we are taking the finite impulse response only. Now the next point is disadvantages of FIR filter. The first disadvantage is complex computational techniques will be there. Large storage requirements will be there because we are approximating the analog to corresponding digital filters. And it cannot simulate prototype analog filters. Now the next point is design of FIR filter by windowing. Now what is the meaning of this? First of all, if I am representing the windowing method, then we can say that suppose if I am taking the input signal like this, and if I am selecting a particular this value, so multiplication of this term with this term, other than this part, it will be considered 0. So 0 into any value will become equals to 0. And this one is 1, then 1 into this value means it will give you that value. But for particular part only, right? So if I am multiplying this particular window with any signal, then it will gives you the output for that particular window only. So this technique is considered as windowing technique. So if you want to design a FR filter but for a particular window only, then we are using this windowing technique. So this will be considered as window techniques. Now if I am representing this signal as in the form of window method, then HD of n will be representing as unit impulse signal from 0 to infinite. This will be multiplied with WR of n. Means we are selecting a particular rectangular window, then it will be representing as WR of n. So what is rectangular window? Suppose if I am taking this as a rectangular window, its value equals to 1. So from 0 to m minus 1 means if we are taking m number of samples, so the term will be 0 to m minus 1. So if we are multiplying this two term, so it will give you the output as a particular selection of this value only, right? So it will give you the output up to m minus 1 only. So this is your final answer, which is representing as h of n. It's a multiplication of this two term, means hd of n is multiplied with wr of. So its value will be ranges from 0, 1 to up to m minus 1. Using this equation, we can derive its magnitude response of this rectangular window. So starting with rectangular window's function, as rectangular window is defined as WR of n, it's equals to 1 for only the range from 0 to m minus 1. otherwise its value equals to 0. So the finite duration impulse response is representing as h of n equals to multiplication of hd of n with wr of n. So in this we had taken hd of n as infinite duration sequence. It will be representing in the finite duration sequence as multiplication of it with a particular. So if we are taking the Fourier transform of this wr of n, then it will be representing as wr of omega equals to summation n equals to 0 to m minus 1 wr of n e raised to minus j omega. Now in this, instead of this wr of n, I am taking 1, because for this range its value equals to 1, right? So I am writing this for this range its value equals to 1 into e raised to minus j omega n means e raised to minus j omega. Now this value representing as a raised to n form. So what is the value of a? Value of a equals to e raised to minus j omega. So if I am representing it in the form of a raised to, for the range of finite duration we are taking a raised to lower range minus a raised to upper range plus 1 upon 1 minus a. So if we will applying this formula, so what is the lower range? Its value equals to 0. What is the upper range? Its value equals to m minus 1 plus 1. Divide by 1 minus a, and the value of a equals to e raised to minus j omega. As you know that any term raised to 0 means 1 minus m minus 1 plus 1 minus 1 plus 1 cancel out, so this term equals to m, so minus e raised to minus j omega n. Divide by 1 minus e raised to minus j omega. Now if I am simplifying this term in the two form, that e raised to minus j omega n by 2 into e raised to minus j omega n by 2. So from that, if we multiply it over here, then the term will be e raised to minus j omega n by 2. This term will be representing as e raised to minus into e raised to plus. So it will be cancelled out. So it will be considered as 1. And this part is dividing into two parts, half half. Same way for the denominator. Now from the numerator, we are taking this part as a common. So e raised to minus j omega n by 2 taken as common. So this term will be representing as e raised to j omega n by 2 minus e raised to minus j omega n by 2. Divide by, over here we will represent, for taking common part as e raised to minus j omega by 2. So what will be the term? E raised to j omega by 2 minus e raised to minus j omega by 2. And as you know that e raised to j theta minus e raised to minus j theta equals to 2j sin theta. So in the denominator and numerator we will representing it in the form of sin. So common part we had written like e raised to minus j omega n by 2 divided by e raised to minus j omega n. Numerator part will be representing as 2j sin omega n by 2. And the denominator part is 2j sin omega by 2. Now from this, if we are combining this two terms, then it will representing as e raised to minus j omega n minus 1 divided by, and this term, in this term 2j will be cancelled out, so this term will representing as sin omega n by 2 upon sin omega by 2. Now if we are taking mode of this, then the mode of e raised to j omega equals to 1 and mode of this will remain as a final answer. So magnitude of this particular window will be representing as wr of omega equals to mode of sin omega n by 2 upon sin omega by 2. Now there are some properties of commonly used windows. The first property is Hamming window. It is given as Hamming window means WHM is equals to 0.54 plus 0.46 cos 2 pi n upon n minus 1. Otherwise its value equals to 0. Over here the value of n equals to 0, 1, 2 up to n minus 1. It is considered as number of samples. Now if we are representing this Hamming window, it will be look like this. So from this diagram you can see that this one is rectangular window. Red color line is considered as rectangular window. And the next one is this cyan color will be representing as Bartlett window. And then next one is blue color will be considered as Hamming window. Then the next color is green color will be representing as Hamming window, and the last one is pink will be representing as Blackman window. So if we want to select a particular portion of it, then it will consider as we will using the different kinds of window. In this, if we are using the more number of factors, then it will be sharpen the edge. So because of it, we can sharpen the edge of this particular selection. So according to that, there will be different kinds of window. The first window is, the next window is hanging window or raised cosine window. So if we are defining this hanging window, it will be defining as HNM of HNM equals to 1 by 2, 1 minus cos 2 pi n upon n minus 1. And its value will be representing like this. So it will be basically bell-shaped window. So particularly bell-shaped window is selection is, it will be done by this hanging window. Now the next window is triangular window or partlet. So if we are representing it, then it will be in the triangular form and it will be representing as the equation as a triangular window will be representing as WT equals to 1 minus 2 mod n upon n minus 1, and the value of mod n will be less than or equals to n minus 1. So because of this tapering of this rectangular window, it will be linearly ending from middle to its ends. So it will be look like this. So from middle to its end, it will be linearly decreasing. So this kind of particular selection will be done by using this triangular window, and it is also known as partlet window. Now the next type of window is flatman window. What is flatman window? It is representing as WB is equals to 0.42 plus 0.5 cos 2 pi n upon n minus 1 plus 0.8 cos 4 pi n upon n minus 1. As you know that if we are increasing the number of cosine terms, so it will be sharpen the edge. So it will be representing like this. So this window is considered as flatman window. Now the next type of window is Glacier window. Glacier window function can be defined as WK equals to IO beta upon IO alpha. For this, mode of n should be less than 0, otherwise its value equals to 0. So from the Basel's function, we can define this Glacier window, where we are using I0 of x is considered as modified Basel's function from of the first kind and 0. And this window is representing as your Glacier's window. Now the next topic is Gibbs phenomenon. What is the Gibbs phenomenon and what is the use of this phenomenon? The impulse response of FR filter is in the form of rectangular window is representing as H of n equals to HD of n into WR of n, right? So the frequency response of this filter can be representing by using the Fourier transform. As I have told you that if we are taking the multiplication of two signals in the time domain, then the corresponding to it in the frequency domain, the convolution of these two things. So if we are representing it in the frequency domain, then it will be representing as h of omega, right? So what is the value of h of omega? Value of h of omega equals to Fourier transform of this two terms multiplication. And if we are simplifying this, then it will be representing as h of omega equals to hd of omega convolved with wr of omega. So by using this equation, we can derive the frequency domain representation of any filter design. Now you can see that if we are convolving these two terms, then it will give you the ringing at the band edge, right? Because of side lobe, there will be ringing, and because of ringing, it will give you the output, which will be less compared to the upper ring one. So this type of phenomenon is considered as Gibbs phenomenon. Now the next topic is advantages of windowing method. The first advantage is simple to implement. The next one is fixed stop band attenuation. And the next topic is disadvantages of windowing method. The first disadvantage is the designing of FR filters using windows is not flexible. So there is no flexibility in the designing of this windowing because we have to use particular equation for designing of particular window. The pass band and stop band edge frequencies cannot be precisely specified because of the ringing and too much complicated expression for the desired filter response. So these are the disadvantages of windowing technique. Thank you so much.